Okay, it wasn't my imagination. Ignore everything from here over, that's a different class. And that's why I didn't recognize what I was seeing. So we did our calculation, we found the work done here. And we found that the change in the 1/2 mv squared is what we had before. Okay, now, this time we used 5 kilograms and worked it out a little more explicitly. Our delta v squared, we didn't actually assume initial velocity of 0. We just calculated the change in v squared. Since 1/2 m is constant, that can come outside of the delta. And we just have 1/2 m times the change in v squared. So change in v squared, and let's be really explicit here, change in is a subtraction. Exponentiation precedes the subtraction. So if we wanted to square delta v, we'd have to put the whole delta v in parentheses. So delta v squared, the way I had it written, means this. It's unambiguous, that's what it means. But just to emphasize that that's what it means, I went ahead and put the parentheses in here. Okay, so just multiply that by 2 and then divide by the mass, and we get our change in v squared. Okay, and we find that v squared changes by 0.5 meters squared per second squared. Now, that doesn't tell us what v changes by, because the change in v itself is different for different values of the initial velocity. So I say, okay, well, if v naught is 0.3 meters per second, you can find vf. Whatever initial velocity on this interval you wish to invoke, you can find the final velocity from this. Okay, and then I left this as a question that you might need to answer. Now, as a reward for watching the video, I'll say, well, okay, then the change in v squared is vf squared minus v naught squared. And that would equal, in this case, 0.5 meters squared per second squared. So if you know v naught is 0.3 meters per second, you can find v naught squared, and then you can easily solve for vf squared. I'll also say that this quantity, that the vf squared will be different for different values of v naught, and that's because you're dealing with squared quantities, they aren't linear, and you can meditate on that a little bit. So you can convince yourself of this. Pick another number besides 0.3 meters per second. Pick 0 if you like, or pick 1 meter per second. You're going to get a different change in velocity. You're going to get the same change in velocity, but you're going to get a different VF every time. And that's a pretty profound thing. So you want to maybe think about that a little bit.